In this video, we're going to have a look at calculations involving speed and how we can manipulate that idea to work out distances and times. So let's have a look at an example. Before we do, please remember to subscribe to our channel for other videos. Let's have a look at a game of cricket. You don't need to know much about cricket to watch this video, but what happens in a game of cricket is a bowler releases the ball and the batter at the other end must react and decide what sort of shot they're going to play to the ball that's delivered to them. So our question for this video is, how much time does a batter in cricket have to react to the ball that's bowled to them so they can make a decision about what sort of shot they're going to play? And just to give you a bit of a guide, here's some examples here shown in real motion and then in slow motion about a ball being delivered in cricket. So let's go through some facts to help us work this out. We can see from the diagram that we've got two red sets of stumps, and that's where the batter and the bowler stand just in front of. And when the ball's released from the bowler, it's going at various speeds. We'll assume for this problem it's going at 140 kilometers per hour. Now the distance between the black crease lines which are in front of the stumps is approximately 19.33 yards. We'll convert that to meters, and that comes out to 17.68 meters. So there's our two bits of information. We've got a speed, 140 kilometers per hour, and a distance, 17.68 meters, that the ball has to travel. How much time does the batter have to react to that? So before we answer this question, let's have a look at some other examples involving speed. How fast do you think a marathon runner would go? Now would be a good time to pause before we have a look at the speed. So the units we express here are meters per second. They seem like sensible units to use for a human running. Whilst a marathon does go for a couple of hours, typically people might run for a few seconds and only cover a certain number of meters. What about the speed for a car in the city? Now we'll assume it's not stopping at traffic lights all the time. So in this case, 60 kilometers per hour is a typical speed for a car in suburban Australia. So we'll notice the units. For the runner, the units are expressed as a distance, in this case meters, per a time, in this case seconds. For a car in the city, the units are expressed as kilometers, that's the distance, per hour, which is the time. So speeds are expressed as a distance per time. We can write that as a formula if we want to calculate a speed, and it's equal to distance divided by time. In other words, distance per time. We can rearrange that formula if we want to work out the time or the distance. So if we multiply both sides of this equation by time, what will happen is the times will cancel on the right hand side, and we'll end up with time times speed equals distance. We'll just rearrange that so it's easier to read. Distance equals speed times time. How do we manipulate that though for the time as well? Well, we can group all of our formulae together in a triangle like this with the D at the top and then the S and T at the bottom. So you'll notice if we work out the speed formula is distance over time. In other words, we can see the fraction in the triangle D over T for distance and time. If we wanted to work out distance, it's speed times time, or multiplied by time. And you can see that in the triangle with the S and T next to each other in the bottom of the triangle. And lastly, time is distance over speed. Again, we can see that in the triangle with D over S. So if we want to work out the time it takes to react to a cricket ball, we're going to use the formula distance over speed. Now the speed of the cricket ball was 140 kilometers per hour. We'll convert that to meters per hour by multiplying it by 1,000. And the reason we do that is because the distance that the ball travels is in meters, so we want to make the units the same. So to work out the time, it's the distance, 17.68, over the speed, which is 140,000. When we do that calculation, we get a time in hours. Now it's unlikely in any sport that you're going to measure the time a ball travels in hours. We need to convert it to something a bit more sensible. So we know on a clock face there are 12 hours represented, and a minute hand goes around that clock face in 60 minutes. That's because there are 12 segments, and each one of those segments is broken up into 5 fragments. You can see that on a clock face there. So there's 60 minutes in 1 hour. So if we multiply our time in hours by 60, we get the number of minutes that the ball travelled. But of course, time for ball sports is usually broken down into very small parts, in other words, seconds. and in 1 minute there are 60 seconds. So if we multiply that amount by 60 again, we'll get the number of seconds that the ball travels from the bowler to the batter. So keeping the accurate value in our calculator of 0.00013, we can multiply that by 60 and by 60 again to get 0.45 seconds. So whilst the time it takes for the ball to leave the bowler's hand to go to the batter is 0.45 seconds, in actual fact, to react to that ball, you'll have to do it in less than 0.45 seconds, because by the time the ball gets to you, you have to make your shot selection. Please note that the formula that we use here for speed is assuming a constant speed, or it's calculating an average speed.